It's been a while since we've worked together.
Yes, it has been.
So probably not on Trig anymore, are you?
Yeah, we just started law of sine.
Oh, okay. What kind of problems you got tonight?
I'm sorry, can you repeat that?
What kind of problems you got? Can you verbalize them?
Yeah, for the most part.
Okay.
I might have to send a couple of pictures, but
okay.
There's just a couple of triangles and the rest is verbal.
Okay.
So the first one, actually, I am going to send this one.
Okay.
Just for the...
Tell me when it's sent.
Okay, I just sent it to your email.
Okay. Hadn't come in yet. There it is.
And the instructions are solve the triangle.
Okay. What's the other angle? It's angle beta.
45 degrees.
Okay. Now, notice what we have. We have an angle and an opposite side. Well, we can use the law of sines to figure out everything else, right?
Right.
So, give me a law of sines that helps us figure out x and y, which is the only two things we need to figure out. So using the law of sines, give me an equation. Start with the known. We know an opposite side is 3, and we know the opposite angle is 45 degrees. So I can always say that the sine of 45 degrees is to 3 as what? Based on the law of sines.
The sine of 50 is the sine of 50 over x.
Correct. There's only one unknown there. It's x. Sine of 45 is a number, sine of 50 is a number. So x becomes 3 sine of 50 divided by sine of 45. You can get that number out of your calculator.
Okay.
Okay? And that gives you x. Now, how do you get y? Remember what the law of sines says.
Sine of 85 over y is equal to sine of 45 over 3.
Correct. In other words, I use that same relationship to solve for y. Sine of 85 over y. And that makes y equal to 3 sine of 85 divided by sine of 45. So that's how you solve triangles using the law of sines. Now, there's only two methods for solving triangles. And that's one, use the law of sines, and that's another is use the law of cosines. You undoubtedly have had both, right?
We haven't done the law of cosine.
Well, you haven't. Okay, that's coming up.
No.
So let's do more law of sines. I don't see a 4 on here. Is it not on here, or do I need to just go to 5?
Oh, that's the only picture one that I had to do.
Okay.
But the next one, it's all verbalized. It's the instructions to solve the triangle, and it gives alpha is equal to 40 degrees, beta is equal to 40 degrees, and size C is equal to 2.
Like that. Well, again, whenever they give you two angles, it means you can always calculate the third angle, right?
Right.
And that means, in other words, if I could not calculate the third angle, I couldn't use the law of sines. Because the law of sines requires you to have an angle and its opposite side. So
Right.
you've got to come up with that to use the law of sines. When you're dealing with the law of cosines, you don't need that. I could actually solve this using the law of cosines, but you haven't had the law of cosines yet, so I don't want to get into that. Let's do this the easy way. What's the third angle?
100 degrees.
Okay. Now I'm going to, you said that was A and that was B, which makes that C. And it makes that little side C, that little side A, and that little side B. You understand the notation with these? Capital letters usually mean angles, little letters mean side length.
Yes.
So, give me an equation that's going to let me solve for little a.
Sine of 100 degrees over 2 is equal to sine of 40 degrees over A. And A and B are equal, right?
Okay, yeah. And because it's an isosceles triangle, so A is equal to B. So all you have to do is solve for A and you've solved the triangle. Solving a triangle means coming up with all three angles and all three sides. So the moment you've done that, you've solved it.
Right.
Okay, what else?
Okay.
Have you had the ambiguous case of the law of sines yet?
We went over it briefly today.
That's the only hard part of the law of sines. You would agree that the law of sines is pretty straightforward on most triangles.
Yeah.
Okay? Let's talk about the ambiguous case of the law of sines.
Okay.
Let's say I have a triangle whose side measurements are 10 and 8 with a 30-degree angle there. Okay? If somebody said solve this triangle, it looks fairly straightforward, right? I've got an angle and I've got an opposite side, and I got an opposite side, so I can figure out that angle. Once I figure out that angle, I'll know this angle. So I should be able to solve this triangle relatively straightforward. But there's a catch. And the catch is there are actually two triangles that fit this description.
Right.
The other one looks like this. Still has the 30-degree angle, still has that side of 10, and still has that side of 8. So when you have an angle side-side, or I'll put it side-side angle to be more politically correct instead of ass, this is still side-side angle, same side-side and angle. So just having a side-side angle does not always specify a unique triangle. In some cases, it specifies two triangles, and that's why they call it the ambiguous case. Is because just saying what the side, and angle are does not spell out what the triangle is. It could be this triangle, but it could also be this triangle.
Right.
That's why it's called ambiguous. Now, let's figure out how to tell when we have an ambiguous triangle. I'm going to show you the easiest way I know how. Let's say they gave you that triangle. Okay, well, first thing I'm going to do is say the sine of 30 degrees relative to 8 equals the sine of x relative to 10. With me?
Yes.
Okay. Now, if I solve for, hold on, the sine of x here, I'm going to put it on the left side, it's going to be equal to 10 sine of 30 divided by 8, correct? Tell me what that angle is.
Yes.
What's the sine of x equal to?
I'm sorry, I don't have a calculator on me. One moment.
You should always have your calculator when we do a session in front of you, especially when you're doing trig, because a lot of these things you can't get without your calculator. In other words, I can't figure out certain angles without a calculator.
Okay, can I go and grab it really fast?
Sure.
Thank you.
Okay, the sine of 30 is 1/2. So this whole thing becomes 10 over 16, which is 5/8, which is 6.625. So that's what the sine of x is equal to. So if the sine of x equals 0.625, what is x equal to? What angle is that? And how do you get it? Make sure you're in degrees.
38.7 degrees.
All right. Now, here's the kicker. Here's how you figure out whether it's the ambiguous case or not. X can actually be 38.7 or its supplementary angle, right?
Right.
In other words, x could also be that, perhaps. Certainly the sine of 141.3 degrees is still 0.625. So both of these angles are definitely true. The question is can we have a 141.3 degree angle? And the answer is yes. In other words, any triangle, the sum of the angles has to be less than 180, right?
Right.
So if this second angle that I came up with works right there, and it does, because the sum of 30 and 141 is still less than 80, then that's a possible solution, leaving this angle to be 8.7 degrees. So the way you figure out whether or not you have not all triangles have the ambiguous case, only certain ones. And I could give you a set of rules as to which ones are possible ambiguous case, but those are tough. They're tough to memorize, they're tough to remember for a long time. The easiest way to do it is this way, where when you figure out the angle, you also figure out the supplementary angle. And then the question is can you also have the supplementary angle? Well, yes, because 30 and 141.3 do not exceed 180.
Right.
If they do, then you just cross this off and you do not have the ambiguous case. So, in essence, every time you are solving a triangle, you are always coming up with both possible angles. Let's say this angle came out to be 151.3. And this one came out to be 28. You with me?
Yeah.
Now, that's impossible. We cannot have a 151 degree angle right there, because 151 plus 30 would be 181. So I would say, no, can't have that. The only angle that you can have is 28.7. And so you would not have the ambiguous case.
Okay.
So the way you tell whether or not you have the ambiguous case is to always figure out that second angle. And then there's only one other known angle, and that's this one that they gave you. And so if that second angle and the one known angle are less than 180, you can have it. If it's more than 180, you can't have it. And that's what determines when you have an ambiguous triangle. In other words, let's do one more. This time I'm going to use same measurements, 10 and 8, only this time I'm going to use 75 degrees there. Now the question is there only one solution to this triangle? Well, how are we going to tell? We're going to say sine of 75 divided by 8 equals what?
Sine of angle C over 10.
Okay. Now let's figure out what sine of C equals. It's 10 times the sine of 75 divided by 8. What number is that? We're figuring out the sine of C. It's not going to be in degrees. First of all, figure out the number, and then we'll take the inverse sine of that number to figure out the angle. But this is a number. Very important in trig that you learn to distinguish between what's going to be a number and what's going to be an angle. You take trig functions of angles to get numbers. You take inverse trig functions of numbers to get angles. So what is this number? What's the sine of 75 times 10 divided by 8?
1.21.
Okay. Now, that tells you something very important. What we just figured out was the sine of C is equal to a number that it's impossible for it to be equal to. Sine and cosines are between 1 and minus 1. You can never have the sine of an angle being a number greater than 1. So that can't be. So the way I've drawn this triangle must be an impossible triangle. In other words, this can't reach the bottom. It's got to go like that and stop. In other words, I cannot make a triangle where I've got 75 degrees opposite a side length of 8 and I have a side length of 10 opposite that angle. Doesn't work. Can't do it. What I was trying to do was show you that this was not ambiguous. And not only was it not ambiguous, it didn't even exist. So, in our last 5 minutes, let me change this really quickly and make this angle 45 degrees. Okay. Now, what is sine of 45 degrees times 10/8? I don't want it to be a number greater than 1. I want it to be a different number, just so I can explain this to you.
0.625.
All right. So I've got the sine of C equals 0.625. Now tell me what C is.
.675.
C is an angle. What is the angle C?
Okay, right. 38.7 degrees.
Now here's where I want to add also the other possibility. What else could C be?
.141.3.
This was a 45-degree angle. Can C be 141.3?
Yeah.
Nope. Notice that I've already got a 45-degree angle in that
over
thing.
180. Right, okay.
That puts it over 180. That means that's not a possible solution. The only C I can get is 38.7 degrees. And that also defines that angle right there. So now I've solved the problem. But that's how you tell whether you have the ambiguous case or not, is you always figure out both angles, and then you figure out whether there's room for that angle. If there's room, then you've got the ambiguous case. If there's not, then you do not. And there's only one solution.
Right.
Okay? And that truly is the only hard part of the law of sines. The law of sines are really, really easy as long as you're not dealing with the ambiguous case of the law of sines. And then it's really tough. But if you use this method every time, it'll make it easy. Really does, trust me. Because the first time I took trig, I had to deal with the old rules. The old rules being this angle's got to be less than 90 degrees, and the ratio of 10 to 8 has to be greater than the sine of that angle, and there's one more requirement. Okay? Well, that's crazy to memorize all those things. Because all you have to do is solve for both possible angles and figure out whether the bigger one fits. If it does, then you do have two solutions. If it doesn't, you only have one.
Okay.
That's it in a nutshell.
All right.
Okay? And unfortunately, I got an 8:30 tonight, so I'm going to have to run. But hopefully that helped you out a little bit.
Yes, a lot. Thank you very much, Mr. Count.
I will talk to you next time.
Have a good night.
You too. Bye-bye.